Okay, ladies and gents, well, good morning, and today we're going to begin our lesson by reviewing some of the concepts we've talked about radicals. You can see that I'm here at coolmath.com under the pre-algebra tab, and I just want to review a couple things about radicals before I ask you to do an assignment, since I'm not there to answer your questions. So we'll begin by doing a review of radicals, and I'm just simply going to click here. I don't believe that it'll be necessary for you to use this site during the hour, but if you wanted to come back here as you're doing homework, once again it's www.coolmath.com. And you'll see I'm just going to click here on the review of radicals, and we're going to do a little bit of review. So it begins here by talking about what does it mean to say the square root. It gives us a couple examples that most of you will probably be very familiar with and probably even snoring through, but please spare us the snores. So we say the square root of 4 is 2, and the reason for that is because whenever we see a square root sign, which is called a radical sign, it means that we're looking for a number within the radicand, which would be this 4, for example, which has a number times itself that equals this number. So we're looking at something, what is it that times itself equals 4? And of course the answer to that is 2. So we simply write 2 for our answer. This right here, the red, is asking what number times itself equals 100, and of course the answer is 10. But sometimes we have some of these more confusing things, such as what is the square root of 7? Well, we all know, even without referencing a calculator, that there is no number times itself that equals 7, no whole number that times itself equals 7. And that's because 7 is a prime number. So we can use these little squiggly lines if you answer it with your calculator and you come up with 2.6457. Just make sure you use these squiggly lines if you're using your calculator. However, it is completely acceptable for any of my tests or any of my classes for you simply to leave a number which cannot be reduced in its radical sign. I guess I was talking kind of quickly there, so I'll just give you a second to pause and catch your breath while I catch mine. All right? So the next thing I want to talk about as we're looking here at square roots and radical signs is that you really should have a calculator, and I've told you this since day one in the class. You need to have a calculator that's not on a phone, and if you are using your phone calculator, you can for classwork, but not for tests and quizzes. So if you have that phone calculator, turn it on its side, and you'll see that it turns to a scientific calculator, but really you need to have a calculator that has the option to push a radical sign. A scientific calculator would work, but isn't necessary. Alright, so let's keep going. This website explains some things to you very nicely. If you wanted to take more time to read it, maybe you did while I was just kind of taking a rabbit trail to give your brain a break. But now we're going to look down here at what we learned in one of the first lessons of Chapter 11, which is if you have a negative within a radical sign, there is what we call no real solution, simply because we can't have a number that is negative times itself, which is also negative, and expect to get a negative answer, because a negative times a negative is always a positive. So an answer for an equation that would look like this purple one, which says the square root of negative 25, would simply be no solution, not real, or no real solution. Okay, we're going to go on to a little bit more of a review. They give you the opportunity here to try this. Go ahead. What is the square root of 9? The correct answer is 3. What is the square root of 37? The correct answer is that you would leave it written just like this, the square root of 37. There's no solution that is a real whole number, so we just simply leave it just like this. You would just circle it, and that would be your answer. What is the square root of negative 16? the correct answer is that you would write no real solution. It would not be correct for you simply to circle this. That would not be correct. You would need to write out the word no real solution. This website then goes into cubed roots, but we're not going to deal with cubed roots. This is where it takes a different path than our textbook does. We'll talk about that more, but not right now. So we're going to go back here to our introduction of radicals and look at just a couple of the rules before I give you your assignment. It's always good to look at a couple different sources, not just what your teacher is telling you. Maybe someone else can explain it a little bit better. Just make sure they're right when they explain it. So we're going to look at this here. Here's a rule for multiplying radicals. And let me just go ahead and explain this. I'll read what it says first, but it says the n root, which of course we're only working with squares, so you could pretend like that n is a 2, the square root of a times the square root of b equals the square root of a times b. That is a correct interpretation of multiplying radicals. What it tells you right here, note that the type of root n have to match. So in other words, if this one right here had a 2, or maybe it didn't have anything, because usually when it's a square root we don't even bother to write the 2. But if it had a 2 there, and then right here it had a 3, that would be as simplified as this equation could be. You cannot combine them if they have different roots. And that's what we call these little numbers right here. They're represented by actually letters there, the letter n. So this is called our root. This sign is called our radical sign. And this letter, which of course is representing a number, is called our radicand. Okay, here's a couple examples of multiplying. When we're multiplying and we have the square root of 2 times the square root of 8, that is the same as, in other words, the rule allows us to say the square root of 2 times 8. Now, the square root of 16 is not our answer because we need to go one step further. We need to factor 16 and find out, is there a number times itself that equals 16? And the answer is yes, 4. 4 times 4 equals 16. So you can write that as your answer to the square root of 2 times the square root of 8. The answer is 4. Okay, we're not going to bother with the cubed root example they give us, but we're going to go down here and look at this example. Right here it says the square root of 5 times the square root of 7. Because our rule that we looked at the beginning tells us that since the root is the same, they both have the square root is what it's asking for because there's not a number here or here. We can then say the square root of 5 times 7, which is the square root of 35. And the words here are you can't pop it. What it means is you don't have two pieces that can pop out. And so therefore you just leave your answer as the square root of 35. One more example to look at. The square root of 3 times the square root of 3 is equal to, or is correctly to be written as the square root of 3 times 3, which is the square root of 9, which we of course know the correct answer is 3, because 3 times 3, or you could say that 3 squared, is 9. Okay, we're almost done. Stick with me because in just a moment you're going to do a little bit of a review over Chapter 11 and what we've studied thus far. Okay, he calls this part a game, and he says that if you wanted to add the square root of 2 plus the square root of 8, could you do it? Well, there's nothing that we can do to take this number down any farther to simplify it. So in other words, the square root of 2 is as small as that can get. But when we have 8, we know that the square root of 8 can be represented by 4 times 2. And we know that 4 is 2 times 2, which is why he represents it like this. And we know that we can turn this blue number 4 into this blue number 2 because the square root of 4 is 2. So therefore, when we're asked to add them together, we can do that simply by keeping this one the same. Okay. Dropping it to here. And we're asked to add the square root of 8. So let's follow the colors. That's why he's using this color to help it be clear to you. If we want to add the two together, we have the square root of 8 is the square root of 4 times 2, because we know 4 times 2 equals 8. When we're saying the square root of 4 times 2, we could also say that as the square root of 4 times the square root of 2. Therefore, we come up with 2 times the square root of 2. So, this first one, that's red, this, the square root of 2 plus the square root of 8 is equal to the square root of 2 plus 2 times the square root of 2. He tells you to treat the radical signs like variables. If you had 1y plus 2y, it would equal 3y. So, since we have here the square root of 2 plus 2 times the square root of 2 equals, has anyone guessed it yet? 3 times the square root of 2. Now that may be a little bit complex, a little bit more difficult than you're able to grasp without a couple more examples. If so, don't panic. I'll make sure that I can review this with you tomorrow. But it's a concept I wanted to introduce to you because I think a number of you are going to understand that concept and perhaps even go to your textbook and look at a couple examples there. And then you'll understand it completely. Your assignment will be on the Google Slides or written on the board, whichever it is that Pastor Dan decides to do for you this morning. I hope you have a great morning, and I look forward to being with you together tomorrow.